Okay, this is just a quick little video showing you how to use Google Sheets to make some graphs. In this one, this is just something I made up for free fall. So here we can see different drop heights, so from point 1 down to 2 meters. And for each height, I conducted 6 trials. So each height would be like a situation, and then there are 6 trials per situation. A lot of data here. The first thing I'd like to do is I'd like to find the average of these time trials. So in Google Sheets, what you want to do is you want to hit the equal button, and that tells the program that we're getting ready to put in a formula. So I'd like to find the average. So just type in the word average, and then in parentheses, what do you want to find the average of? Well, I want to find the average of this. Just highlight the numbers that you want to find the average of. Then when you press enter, you'll get your number up here for your average. So when I click on this box again, notice that there's a little tiny square at the bottom right. I'm going to click this and drag it down. And what that does is it finds the averages for each one. So if I click on one box and then look up at the formula bar, I see that it's the average of B12 through G12. If I click on this one, it's the average of B16 through G16. So it's a real nice way to find averages. The next thing I like to do is I like to make a plot of this data. So I'm going to highlight this data. I'm going to come up to Insert. I'm going to insert a chart. Now the type of chart I want is a scatter plot. In physics, we always use scatter plots. While I'm here, I'm going to click on Customization. And I'm just going to, for the title, I'm just going to put Experiment, because this our experimental data. This is my experimental data. And then for my horizontal axis, that's my average time, measured in seconds. For my vertical axis, that was height, measured in meters. Coming on down, I'm going to add a trend line. So if I click linear and then click on R squared value, I see it's 0.97. That's not very good. And we can see that the line doesn't really match the data. So I'm going to click on polynomial. Now I got an R squared value of 0.999. The closer you get to 1, the better. And for the label, I'm going to use the equation as the label of this. And then I can go ahead and click Insert. And there I have my graph of my experimental data. I'm just going to move this down here. Well, the next thing I might like to do is compare that graph against something, and I might like to compare that graph against maybe a predicted value. So here I like to put in my predicted times. Now, the way I would calculate this, it'd be the square root of 2 times the height divided by the acceleration due to gravity. That is the formula for predicted height. So since I'm getting ready to put in a formula, I hit the equal button, and this time square root, SQRT. So I'm going to find the square root of something, and you always want to have your parentheses. So on the top, it's 2 times the drop height. So in parentheses, I'm going to do 2 times the drop height, and I'm just going to click on the drop height. That divided by prime 0.81 is the acceleration due to gravity. So when I click enter, that tells me what my predicted height is, and then again I'm going to click on this tiny little box to the right and populate this list down. That gives me all of my predicted heights. Okay, I'm going to go ahead and highlight all of this data. Go up to Insert, Chart. Again, I'd like to use a scatter plot. For customization, I'm going to do predicted horizontal, this is my predicted times measured in seconds. For my vertical, height measured in meters. Going to come down to add a trend line. Again, we see that linear doesn't really do it. But if I go to polynomial, my r squared value becomes 1. And for a predicted value, your r squared value should be 1. It's predicted data. I'm going to use the equation for my label and go ahead and click insert. And then I can bring this, I can start to compare these two charts. So some things I see right before the x squared on my experimental data, it was 5.004. For my predicted, it was 0.49. That is very, very close. So in this type of simple experiment, I see that my experimental data is very close to my predicted data, which is what I would hope to see. Now, the next thing I'd like to find is the precision of my experiment. In physics, the way we find precision is by taking something called the standard deviation. So I'm going to hit the equal sign again, and I'm just going to type in ST, and right here, the first option is standard deviation. Now I want to find the standard deviation of some values. Well, if I come back over here, it's going to be the standard deviation of my 6 trials. So there I have my standard deviation, 0.017. Now, ideally, the smaller you can get this, the better. So now I have this. I'm going to go and populate this list down. So if I click on this last one, I see it's between B32 and G32, which is what I want. And really, this is pretty good data. A lot of these standard deviations are in the thousandths, or at least the hundredths. So yeah, this is pretty good. And again, the smaller this number, the more clustered together your data was. The next thing I might want to find is the accuracy. And you remember that the accuracy is to take the measured value minus the predicted value divided by the predicted value, and then you turn that into a percentage. In chemistry, you might have used accepted values. We use accepted values every now and then, but accepted and predicted are kind of like the same thing. So let's put in our formula. So if we think about it, I'm going to have something times 100 to turn it into percentage. So inside this, then, I have something on top of an equation divided by something. So on top, I've got my my measured value, so I'm going to use the average for that, minus my predicted values, and all that will be divided by my predicted value. And then we populate this list down, and then we can find the accuracy in terms of a percentage. So I'm going to put a % sign up there. So my percentage for each one of these. So this first one's 0.78%. The minus sign just means that it was below the predicted value. Any positive signs means that it was above the predicted value. So 5%, 2%, really anything less than 10% is pretty darn good. So I think my biggest one here was a 5%. Yeah, that one was my biggest one, which is what I would expect. That concludes this.